All right, so I want to start today with working on those pieces that we left off with yesterday. We'll do a quick refresher here, and then I want you to work with a partner to do the rest of these. So I'll go through the refresher. This is in your book on page 75, and then you guys are going to be working with your partners while I'm taking attendance. So this is kind of like bell work, but with a little lead in, all right? Page 75 in your books. We're doing this without calculators. We're just using some reasoning skills and mental math and powers of 10, because it's easy for me in my head to multiply and divide by 10. It's like adding a zero or moving the decimal point. So we've got this fact right here, that 13 times 17 is 221. So as I'm looking at this, I want to see what I would need to do to that so that it would look exactly the same as this one up above it. What would I do to this so that the 13 times 17 looks like this? Add zeros. Mathematically, how do I add zeros? Multiply. If I multiply by 10, it adds how many zeros? 1 0. I want to add 2 zeros, so I would multiply by 100. So we're going to take the 17, we're going to multiply it by 100, and now would it look the same as what's above it? Rules of algebra say if you do it to one side, you do it to the other side. Well, the other side had been a 221, but I need to do what to it? Yep, multiply it by 100, which would add 2 zeros on the end. So what's this going to look like? 22,100. Thank you, ma'am. All right. Same idea for the one down below. Because 1.3 and 1.7, visually that looks a lot like 13 and 17, right? Okay, so if I have 13 times 17, what would I need to do to the 13 to make it look like 1.3? Divide it by 10. So I'm going to just do this a step at a time so that I can watch us walk through it. I'm going to divide it by 10 first, so that that would give me 1.3 times 17. But if I do it to one side, I got to do it to the other side. So I would do 221, and I would divide that by 10 also, which would give me what? 22.1. I'm not quite there yet, but I'm closer. So I have 1.3 times 17 equals 22.1. How can I make the 17 look like 1.7? Divide that one by 10. And if I do it to one side, got to do it to the other side. So if I do that, I have 1.3 times 1.7. How's that going to change the answer? It's going to move again. So this is going to be 2.21. Those of you that were here yesterday, that should leave you with 3 problems left to do. E, F, and G, right? Because we did A and B yesterday. If you missed writing one of them down, you'll want to fill that in. E, F, and G all use what operation, though? Division. So before I set you loose and before I take attendance, let's talk about what I could do here. This says 13 times 17 equals 221. What does E look like? Problem E. That's 2,210 divided by 13. So the first thing I want to do is make this look as close to what's on my page as possible. So I would want to divide by 13 on both sides. I would have 17 equals 221 divided by 13. I'm going to use the same divided by symbol that they have. And now from here, can I use the same kind of reasoning? I want you to work with your partners. If you're really stuck, get up and walk around the room and find somebody that looks like they know what they're doing while I take attendance, okay? All right, so I'm curious what you guys came up with. For E, what did you come up with? 170. Let's talk about how you can do that without just grabbing your calculator or without doing the whole algorithm. So we know 13 times 17 is 221. And then we talked about how if I divide both sides by 13, I can get 17 equals 221 divided by 13. That's starting to look much more similar, right? Granted, I'm comparing left side and right side, but this still looks a lot like this, right? So what would I need to do to the 221 to make it look like 2,210? Multiply it by 10. And if I do it to one side, you have to do it to the other side. So I would have 170 equals 2,210 divided by 13. So that's how I got that without using my calculator. I want to try to apply almost the same reasoning to part F. So on part F, I'm still starting with the same fact. 13 times 17 equals 221. Do I want to divide by 13 this time?
No.
No, because I want to make it look like this. So I'm going to divide by which piece? Divide both sides by 17. So that would give me 13 equals 221 divided by 17. This looks pretty similar to this one up here now, but not identical. What's different? The zeros. How many more zeros do I want? 2. So what do I need to do to give it some extra zeros? Times it by 100. And if you do it to one side, do it to the other side. So that means this would be what? 1,300. Because I'm going to times this by 100, times this one by 100. My pen keeps falling apart. So I'm going to bring my work over here. So I would have 1,300 is equal to 22,100 divided by 17. We okay with that so far? You guys kind of understanding what we're doing a little bit better than maybe when we first looked at it yesterday? Let's do this last one, because this last one's a little bit more challenging. In fact, I'm going to bring him over a little bit higher up on the screen too, so that everybody can see what we're doing. So I'm going to bring him over here. So the first thing I want to do is make my rule look as much like my problem as possible. I see that it has division here. What should I divide by? What What should I divide by? I want whatever's after it to be the thing that I divide by. So what looks the most like that? The 13. So I'm going to divide both sides by 13 to begin with. All right. So I would have 17 equals 221 divided by 13. What would I need to change about the right-hand side so that it looks exactly like this side? I need to divide the 13 by 10. So here's where it gets a little bit weird. I'm going to write down another way of like looking at this or thinking about it. So I'm saying I need to do this, but then I need to take the 13 and divide it by 10. So what we're saying is that I need a fraction in the denominator of my fraction, right? Because that's how I would get a 1.3 down there, right? Okay. This would be 221 divided by 1.3. So that looks right over there, right? But now I got to figure out how to do that to the other side. Because on the other side, I don't have division, and I certainly don't have a fraction on the bottom of my division, right? Does anybody remember the special rules for how to divide by a fraction? Yeah, it's the same as multiplying by the reciprocal. Same thing as multiplying by the reciprocal. So this is 221 times 10 over 13, which means I'm really multiplying by what? Because this is kind of like this. We're multiplying by 10. Kind of feels weird, doesn't it? I would need to multiply this side by 10. So this one's going to come out to be 170. We can spend some more time talking about that one later. That was the hardest one on here, and that was definitely a stretch. We'll revisit this idea later. If you didn't quite follow that last one, don't sweat it, okay? I want to kind of switch gears, though, and I want you guys to flip forward in your books to page 77. Page 77 in your books. Do not show anybody else the work that you're doing down the left-hand side of your page, all right? You are going to pick a number, any number. Keep it small. There's something between 1 and 20. Don't make it humongous because I'm going to ask you to do some mental math with it, all right? So pick a number between 1 and 20, and I want you to write it in this box right here.
Is it where we're all going to get the same number? Is it the one we get all that same number?
I don't know.
So the second box, right, or the first one?
You put your number in the very first box. Yep. And then I want you to write the instructions because we're going to refer back to these instructions all along the way. So pick a number, any number, put it in that box. Then whatever number you picked, I want you to take it and double it. And you're going to write that here. So whatever number you picked goes in the top box. You need to be able to see that still. You're going to take it and double it and write it in this second box here. So far, so good? All right. Now, whatever answer you have in that box, I want you to add 6 to that number. So you're going to add 6 to whatever was there and write it in this third box. Everybody doing good so far? You've picked out your number, you've doubled it, wrote it down. Then you took that new number after you doubled it and you added 6 to it, right? Okay. Now take whatever you got after you added 6 and divide it by 2. So to go from here to here, you're dividing by 2. So you're going to put that right here. We doing all right? There's one more step I want you to do. Whatever your original number is, so the one that you wrote way up here, you're going to subtract that from whatever you just got right here. So you're going to subtract your original number.
What if our original number is smaller than our number that we divided with? Do we take the bigger number and like make sure it's positive instead of negative?
Let me walk through the steps again and make sure that we're understanding all along the way, because we shouldn't end up with any negative numbers here. Everybody's number should come out positive, because you were supposed to start by picking a positive number, something between 1 and 20. So whatever you picked at the beginning, you're going to double it, which would mean to do what to it? Add it to itself, or you could also multiply by 2. Both of those would be ways of doubling it. So it's going to get bigger right here. And then you're going to add more to it, right? Whatever you got after you doubled it, you add 6 to it. So now it's even bigger. After you've doubled it and after you've added 6, you're going to divide it by 2. So you'll cut it in half. And then whatever you have here, then you'll subtract your original number from that. Double check your calculations. You should have a positive number. Once you've had a chance to double check all your calculations, and you've written it down, I want you to fold your paper hot dog style so that your neighbor can't see it and I can't see it. I'm going to use my psychic powers to try to guess what your answer was. Now I gotta find my little post-its. All right. So I'm going to write on the back of a Post-it note, and I'm going to put it down. Do not pick up the Post-it note until I've got to everybody. I'm going to try to guess everybody's numbers. Again, not their original numbers, their final answer. Ready? No peeking.
So what? You said you see me.
Now I exhausted my Spanish abilities.
Why did she look? Why did she fall?
Watch her playing. No, I know. I did do it. I'm just saying. I know what this is. It's a trick. Everybody gets it.
It's a trick. You don't have a trick, you.
I just did it in my phone.
Yeah, but you have to be small numbers.
It says trick. It says stop. Everybody's last answer was three. The last answer was three, right? You must have not did that.
Now you have help. My teacher said I could.
Bro, it's, she said that's in y'all, bro.
Sorry.
No, I just tried it with, I put, look, I'm
Alright, what's the
well, that's it.
Yep. You guys can look at them. How did I cheat?
Bro, what?
How did I cheat?
I figured it out before you did. Everybody has three.
Okay.
Everybody answers three. If you did it right.
So, yeah, I had to get smart. Third period, I used a pen that showed through my Post-it notes. So I used an orange pen on pink Post-it notes because you can't see through them. All right, so I'm curious. AB called me out on this, but he's not wrong. He's not wrong. So I'm curious, though. Does that mean that you all started with the same thing?
No.
Jose, what did you start with? 7. Fabija?
7.
You chose 7. Asasia? 2.
I was gonna put 17.
3, 8. People started with different things, but somehow, through what I asked you to do, I forced everybody's answers to be 3. So now I want to know, how does that work?
Because you gave us all the same direction.
I gave you all the same directions, but think about that. If I tell anybody to pick out a number and multiply it by 5, you don't all get the same result, do you?
I think you did because you gave us a range of numbers to choose from. You said 1 to 20. So out of all those, that's where it can work on.
That is a good thought. However, I could have told you to go up to 1,000 or 1,000,000. I just wanted things that you could do easily in your head. Yes, sir.
So you doubled it and then you divided it, so that cancels out. When you added the 6, pretty much all you did was divide 6 by 2, and you just got 3.
Hold up, guys. Edgar's thoughts on this are fantastic. Would you mind saying that again just a little bit louder?
So you doubled it and then you divided it by 2, so that cancels out.
We doubled it and we divided by 2. Those are operations that cancel each other out.
So you subtracted your original number.
We subtracted the original number. Sorry, I'm going to repeat it louder so that everybody can hear.
And then when you divided it by 2, you divided the 6 by 2, so you pretty much just got 3, and it makes 3.
I had you add 6 and then I had you divide. That's where the 3 came in. Let's look at this. Go to page 79 in your books. You have 3 columns, but you don't have the writing in the middle. I do want you to add the writing in the middle. We're going to represent exactly what was going on here. First, we're going to represent it symbolically. And then we're going to get over here to representing it algebraically. So, when I told you guys to pick a number, any number, did I know what number you picked? No. So I'm going to represent that with a symbol. Thank you, sir. I'm going to use a star. Are you guys okay with that? Because I had no idea what you had. For all I know, you wrote a heart emoji or a smiley face on your page when I asked you to pick a number. So if I'm using a star in my own mind to represent the number that you picked, what would happen to that star when I tell you to double it? Then it would be 2 stars. Okay, so taking that and moving on to the next step, we would still have 2 stars, and then I wanted you to do what? Add 6. 6 stars? I didn't tell you to do 6 of the thing you had picked, right? So I need a different representation. Can we just maybe use dots?
Yeah.
Okay, so 1, 2, 3, 4, 5, 6. So 2 of something I don't know, and then 6 more of something else. You guys okay with this so far? This is the part that Edgar really picked out real quick. When I heard him say this, I was like, yes, right there. What did I have you do after this. Divide it by 2. Dividing things by 2 is the same as cutting it in half. So if I take 2 stars and 6 dots and I cut it in half, what would I have left? 1 star and 3 dots. So that's what we take on into the next step is 1 star and 3 dots. But then I told you to do what? Which piece in this representation here is your original number? The 1 star. And so that would leave everybody, no matter what the starting number was, with what? 3 dots, or in this case, it'd be the number 3. I want to take that right there. Now that we've kind of understood it abstracted just with shapes and counters, let's build an algebraic representation. Over here, when we were modeling it, I used a star for whatever number you had picked. In algebra, what do we call things that we don't know normally? X. So when I told you to pick a number, it was some unknown thing to me. How would you represent doubling that? Not x squared, that would be x times another x. 2x, because now we had 2 of them, like those 2 stars over there. When I told you to add 6, 2x plus 6. And then I asked you to cut it in half. X plus 3. So I can take 2x plus 6. When I cut it in half, I cut both parts in half. 2x gets cut in half, and the 6 got cut in half. And so then I'm just left with x plus 3. And then I asked you to subtract your original number. What is that original number? X minus x cancels out, and we have 3. Does that make sense? All right. I want to play another little game like this. Another math trick, if you will. I'm going to demonstrate it first, and then you guys are going to play with a partner. You guys have the directions for this on page 78, all right? And actually, I want everybody to kind of follow along. Yes, absolutely. I want everybody to follow along with me. You're going to need a calculator. You can use your cell phone calculator, that's fine. Or you can come up and grab one of my yellow calculators. I'm going to use this to guess your birthday. As long as you do these directions correctly, I will be able to guess your birthday. Okay? Yep. I do not have the time to look everybody's birthdays up in Skyward ahead of time. Not kidding. I'm taking grad classes right now. I don't have enough time to sleep, let alone look up everybody's birthdays. All right, are you guys ready? Okay. So here's what I want you to do. It's really, 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 really important that you hit equals or enter in between each step. If you don't, it won't come out right, and my wonderful trick won't work.
Wait. Say it again.
Yep. You have to hit enter in between each step.
All right.
Or else my trick won't work.
Enter.
So I want you to enter the month that you were born into the calculator.
Like 0 and then the number?
You can do 0 and then the number, or you can just do the number. Like if you were born in May, you can just put in 5. You ready? Hit enter. I know. I just, in between every step, you're going to hit enter.
Need the equal sign.
Yeah, equal sign. Huh? No, phone calculator, you should have an equal sign.
Well,
Yep.
what's the first step?
First step, take the month that you were born as a number. So if you were born in May, you'll put in a 5.
Oh, I did.
If you were born in August, you'll put in an 8. And then hit enter or equals. My yellow calculators have an enter key. Yours have equals on the phones. Multiply that by 7.
Why you keep shaking it?
And then hit enter or equals. So far, so good? Okay. Whatever number you have right now, after you took your month and multiplied it by 7, minus 1. And hit enter. You doing good? Multiply that by 13. And hit enter. We ready for the next step?
Can you restart?
Yep. You put your birthday in. Okay.
I have a birthday.
Put your birthday in, or month of your birthday. Times that by 7. Hit enter. Minus 1. Hit enter. Times 13. Hit enter. Okay? Add the day you were born.
Plus 30.
Yep, so like I was born on the 23rd, so I would do plus 23. Add the day.
She know what she doing. No, she already for the answer.
Add the day.
She not gonna know mine.
I mean, if you put the right numbers in, then I will. Everybody got the day added? And you hit enter?
Yeah.
Add 3. Add 3. Did everybody add 3 and then hit enter?
Okay. Yeah.
Multiply that by 11.
So much.
I know. Multiply it by 11. You guys ready for the next step?
I don't know. I'm looking at my messages. It's my favorite video. Look, it's my favorite.
Oh my goodness. All right, the last thing everybody did was multiply by 11, right?
Yes.
Subtract the month. Subtract the month that you were born.
Oh, I feel like I see what's going on here.
Did you subtract the month?
Yep.
Subtract the day.
Tell me.
If you guys get lost, you have these directions on page 78 in your book. All right. Have you guys subtracted the day?
Yes.
Divide by 10. Quiet. Did everybody divide by 10?
No.
2 more steps.
Look at our age.
You good?
Yeah.
Add 11.
Oh.
Add 11.
Oh, it's my birthday. Damn, that's my birthday.
Divide by 100.
All that, she trying to stand off. She trying to,
March 9th. October 8th.
she know your name now. She got it wrong.
May 14th.
Yeah, I know. It's my birthday.
June 17th. Close to my birthday.
No, but it's only right.
That's not, that's not.
This is not right. What did I do wrong? Oh, yes,
We'll figure it out. We'll figure it out.
My birthday's now. I thought I did it right.
December 1st. Question extra credit. Figure out how it works. There is a regular homework assignment tonight.
Can we just guess and then or get full credit?
If you're correct, if you manage to guess correctly, I will be beyond impressed.
I'll leave it up.
Extra credit if you can figure out how it works. How did I figure out your birthday?
I understand the lot of cards. How you did it? You went back.
Yay! Congratulations, seniors. Seniors won the bulletin board contest. The bulletin board contest. Hold on. So guys, the homework tonight is called chocolate math. Like we did the math magic trick, this one's called chocolate math. I want you to work through it and then once again, figure out how it's working. How could you represent this idea? All right?